Dear friends, welcome to EPG Pathshala. I am Dr. Nitesh Goyal from DAV College, Chandigarh. I am going to present before you the 29th module titled Analysis of Variance under the paper Tourism and Hospitality Research. The module will cover the following topics: the introduction, the ANOVA, the types of ANOVA, the assumptions of ANOVA, then the process for conducting one-way ANOVA, and the SPSS output sheet for one-way ANOVA, and we'll end with the summary. Dear friends, after the completion of this module, you will be able to understand the meaning of the test of ANOVA. You will be able to understand how ANOVA works. You will also be able to understand how to interpret the results. First of all, I would like to give you an introduction about the topic. Research is a topic which has been classified as science as well as an art. This means that research follows a predefined process in order to make research by one fellow comparable by another. It also means that research is a discipline in which a researcher becomes more apt to practice. Once the research problem has been formulated, research design and measurement and scaling details have been outlined. The next stage in research process is data collection and the data analysis. Data collection refers to the stage where the researcher collects information in order to test the hypothesis and meet the research objectives. In this stage, the researcher uses various secondary and primary data sources to collect information which is required for testing the hypothesis. Once the data has been collected, the next step in research process is the data analysis. Data analysis is the process by which sense is made out of the data gathered. It is important to mention that the data analysis can be done on the data which has been gathered from qualitative or the quantitative methodology. In simple language, data analysis is the process of testing hypotheses through various statistical tools. Therefore, data analysis is a systematic process of applying statistical tools to make sense of the data collected within the premise of the research objectives and answer the questions, test the hypothesis, and many a times support or disapprove a theory. The process of data analysis consists of multiple phases. The first phase of data analysis is data processing, which basically refers to organizing the data for analysis by arranging it into rows and columns. Softwares like SPSS are used for statistical analysis. Therefore, in our case, data processing refers to inputting the data into software specific format. Therefore, data processing refers to structuring the data so that it can lend itself to analysis better. The structured data is referred to as the data set. The second stage of data analysis is data cleaning. Data cleaning refers to removing errors from the data set. These might be in the form of incomplete data, duplicate entries or typing errors. In simplest of forms, data cleaning refers to identifying inaccuracies in the data and removing them. The third stage of data analysis is exploratory data analysis. Exploratory data analysis refers to the process of generating means and median for the data in order to understand the basic nature of the data. This is done in order to identify the messages hidden in the data and to develop an insight into what form of detailed analysis can be undertaken on the data. The next phase of data analysis is developing and applying models for testing the hypothesis. Algorithms like correlation, ANOVA, factor analysis, cluster analysis, discriminant analysis, etc. are applied to find relationships amongst the variables and also to test the nature of this relationship. For example, regression analysis is used to explain variation in sales on the basis of independent variables like advertising, sales promotion, etc. It is important to note here that it is the product of the researcher to choose a pre-existing statistical model or to develop a new one. The choice depends upon the research objectives being pursued by the researcher. Therefore, the data analysis process is the data analysis techniques are divided into three broad categories. These are the univariate analysis, bivariate analysis and multivariate analysis. Univariate analysis refers to an analysis when there is only one variable in the study. The common techniques used in this analysis are mean, median, mode, standard deviation, etc. The bivariate analysis is an analysis when there are two variables involved in the study. The common techniques used are the correlation, bivariate regression, t-test, ANOVA, etc. Thirdly, the multivariate analysis is an analysis where more than two variables are involved in the study. The common technique used for this analysis are multivariate regression, discriminant analysis, logistic regression, MANOVA, factor, cluster analysis, etc. The present module discusses one of the techniques of bivariate analysis, that is ANOVA or the analysis of variance. ANOVA is an analysis tool which uses a set of algorithms to find the difference among the group means of a particular variable. ANOVA is associated with statistical tests to find if there is a difference in the means of groups being studied. Conceptually, the procedure is similar to t-test. Therefore, ANOVA is used to test and compare the means of two or more populations. The null hypothesis of ANOVA typically states that means that are equal. The alternate hypothesis of ANOVA states that there is a significant difference in the mean perception of the variables being measured. Hence, HO, that is null hypothesis, will be means of two or more populations are equal H1 the alternate hypothesis, there is significant difference in the mean perception of two or more populations or group. It is important to note that ANOVA must have dependent variables, that is metric, or say that can be measured on interval or ratio scales, and must have an independent variable which is a categorical, that is non-metric in nature. The categorical variable is also referred to as factors, and the levels which exist in the factor are referred to as the treatments. For example, if we are trying to analyze how perception of the facilities provided in a particular restaurant vary across the country of origin of tourists, then the number of countries being studied for research would make treatments, and the country of origin would be referred to as the factor. Now friends, let's take the difference between the ANOVA and the t-test. Now, the difference can be studied on the basis of different parameters, like can analyze the group differences. Yes, the t-test and ANOVA both can do it. How many levels per variable? T-test has only 2, ANOVA has 2 or even more than 2. The test statistics that is used under the t-test is the t-score, whereas in case of ANOVA it is the f-score or the f-ratio. And fourthly, the p-value can be calculated using the t-score, sample size and the number of groups or the degrees of freedom under the t-test, whereas under the ANOVA it is the f-score, sample size and the number of groups, that is the degree of freedom. Now, the types of ANOVA. ANOVA can be used in 3 ways. First of all, the one-way ANOVA. In this type of ANOVA, the analysis concentrates on independent variable and not on the number of activities in each variables. For example, difference in perception of facilities provided in a particular restaurant can be assessed on the basis of country of origin of the tourist, and the country can have 2 or 20 different countries. Second, the two-way ANOVA. In this type of ANOVA, the analysis is done using 2 independent variables. In this methodology, interaction effect between the 2 independent variables can be studied. For example, in the above scenario where the perception of a particular restaurant is being assessed on the basis of the country of origin of the tourist, adding an additional dimension of gender would make it two-way ANOVA. The third type is the multivariate ANOVA or MANOVA. In this type of ANOVA, the analysis is done using n number of independent variables. For example, if we add education, age, etc. to the previous example, it becomes multivariate ANOVA. It must be noted that though all 3 forms of ANOVA, that is one-way ANOVA, two-way ANOVA and multivariate ANOVA, can be done in most of the softwares. Out of these, one-way ANOVA is most popular. The two-way ANOVA goes into the category of general linear modeling, or in short GLM. Now, the ANOVA is based on some of the assumptions. In every statistical test, there are a set of assumptions which the data needs to fulfill before the test can be applied on the data set. Hence, in case of ANOVA, there are 6 assumptions which the data set needs to fulfill before ANOVA can be applied on the data set. Most of the softwares will give an output sheet which will test the data set for these assumptions. These assumptions are: first, the dependent variable should be measured on interval or the ratio scale. That is, it should be continuous in nature. Second, the independent variable should be categorical in nature and have 3 or more categories. There should be independence of observations. That is, there should be no relationship between the observations in each of the groups being started. Fourth, the data set should not have any significant outliers. Fifth, the data set should have normal distribution in dependent variable for each of the categories of the independent variable. Lastly, the data set should have homogeneity of variance. That is, the Leven's test is used to test data set for this assumption. We come on to the process of conducting this one-way ANOVA. Friends, there is a 5-stage process for conducting one-way ANOVA. The first is identify the dependent and the independent variables. As discussed in the previous section of this module, it is important for the researcher to understand the independent and dependent variables for the study. In ANOVA, dependent variable is y, while as an independent variable is denoted as x. So, x is the categorical variable with the number of categories equal to c, and the sample size in each category of x is n. The total sample size will be n is equal to small n into c. Second, decompose the total variation. One-way ANOVA involves the decomposition of the total variation observed in the dependent variable. The total variation in the dependent variable y is denoted by SSY or sum of squares of y. SSY is decomposed into as SSY is equal to SS between plus SS within, where between and within the effort to the categories of independent variable, that is x. The SS, that is sum of squares within the group, refers to the variation in the observation of the dependent variables within a specific group of independent variable. The assumption of ANOVA is that groups same variation in the population. These independent variations are combined together to get the overall variance. The SS between refers to the variation in the observation of the dependent variable across the groups of independent variable. If null hypothesis is supported by the data set, then variance estimate based on SS between is correct. However, if null hypothesis is not supported, then SS between is usually too large. Third, measure the effects. The strength of the effects is measured in this particular step. The strength of effect of x on y as per the formula on your screen. Now, next step, test the significance. In this step, the support for null or alternate hypothesis is analyzed. As discussed earlier also, HO, the null hypothesis. Here, the means of 2 or more population are equal, and the H1, the alternate hypothesis, there is a significant difference in the mean perception of 2 or more populations or group. Now, the conventional alpha levels. If p is less than 0.05, accept the alternate hypothesis, and if p is more than 0.05, accept the null hypothesis. The fifth step, interpret the results. The last step of one-way ANOVA is to interpret the output sheet generated in one-way ANOVA. Now this is how the one-way ANOVA will be presented in SPSS sheet. This is explained with the help of an example. In 2001, Goa's share of total foreign tourists coming to India was 4.78% of the total foreign tourists arrival in India. This share of Goa of the total foreign tourists coming to India has decreased to 2.47% of the total foreign tourist arrival in India. The empty beaches and shacks are a point of concern for the incumbents in this industry in Goa. The incumbents of the industry hire a researcher to study the factors affecting this customer satisfaction. The researcher, as a part of the analysis, wants to compare the customer satisfaction from Goa in terms of foreign tourists. The countries under analysis included United Kingdom, United States of America and Europe. As a first step to the analysis, he analyzes the data using ANOVA. In statistical software, that is the SPSS, first you will go to Analyze, then Compare Means and then One-way ANOVA. Now you can see it on your screen. Then move the dependent variable into the marked column and independent variable into the factor 1. Then in the third step, in options, ask for two outputs to test the assumptions of ANOVA, descriptive and homogeneity of variance by clicking on the options bar. Then click Continue and OK. In the fourth step, first output table is the descriptive table. You can see this table. This table outlines the exploratory aspect of the data set. As illustrated in the following figure, the descriptive table outlines the number of categories in the independent variable. In the current example, the number of categories refers to the country of origin of the foreign countries, that is United States of America, United Kingdom and Europe. The table also tells us the number of respondents in each one of categories and overall. In the current example, the total data set is of 100 respondents, which you can see in the column 2. UK has 47 respondents, United States 17 respondents and Europe 36 respondents out of the total data sets of 100 respondents collected by the researcher. The mean value for UK 3.34, for USA 2.87 and Europe 3.18. This is visible from the third column. Similarly, the table also gives standard deviation, standard error and the maximum and the minimum values. These descriptives are used in reporting the results of ANOVA. The reporting methodology has been discussed in step 6. Before that, let's have the fifth step. The second output table is the test of homogeneity of variance, as you can see in this table. Now, please recall one of the primary assumptions of ANOVA is homogeneity of variance, that is, variance of each group is same. In order to apply ANOVA, it is important that we accept the null hypothesis, which states that there is homogeneity of variance in groups. As discussed before, the p-value has to be greater than either 0.05 or 0.01. That is, if p is less than 0.05, accept the alternate hypothesis. If p is more than 0.05, then accept the null hypothesis. In the above example, p-value of the test of the homogeneity of variance, that is Leven's test, is p is equal to 0.873, that is p more than 0.05. Now, the Leven's test is p is equal to 0.873, that is p is more than 0.05. Therefore, there is homogeneity of variance across all three groups. According to the second output table, the p-value of the test, that is p is equal to 0.012, that is p less than 0.05. Therefore, using the norm p less than 0.05 is equal to accept the alternate hypothesis, p more than 0.05 accept the null hypothesis. We can say that in the above example, we accept the alternate hypothesis and reject the null hypothesis. Therefore, the results of the data sets indicate that there is significant difference in the mean perception of foreign tourists across the countries of origin. To further analyze the results, it is important for the researcher to conduct post hoc analysis. The step 6. A post hoc analysis is conducted by following the same step outlined from 1 to 3. However, after step 2, one has to select post hoc and then Tukey. It is important to note here that the data set cleared the test of homogeneity of variance, and therefore we can apply and interpret the Tukey. In case the data set had failed the test of homogeneity of variance, then the researcher has to use one of the other post hoc analysis given under the scheme of equal variance not assumed. Here from this table, the test indicates that there is a significant difference in the mean customer satisfaction across USA and UK. This is indicated by the p-value, that is 0.009. However, the same colony also indicates that there is no significant difference in the mean customer satisfaction of Europe and USA, Europe and UK. It is important to note here that in order to facilitate the universal understanding of the results and comparability of results across studies, there is a set format of reporting these results. The test results of ANOVA are reported as follows as per the APA format. One-way ANOVA between subjects. ANOVA was conducted to compare the customer satisfaction across foreign tourists. There was a significant effect of country of origin on customer satisfaction at the p less than 0.05 level for the three countries, that is F2,97 is equal to 4.65, where p is equal to 0.012. Post hoc comparison using the Tukey HSD test indicated that the mean score for the UK, that is 3.34, and standard deviation 0.588 was significantly different than UK, where the mean was 2.87 and standard deviation was 0.53. However, the Europe with mean value 3.184 and standard deviation 0.51 did not significantly differ from UK or USA. Taken together, these results suggest that COO of the foreign tourists has effect on the customer satisfaction, and therefore further analysis should be done across the COO of the foreign tourist. Therefore, one-way ANOVA only indicates this significant difference in the mean perception across the groups. The post hoc analysis further helps understand the categories across which the significant difference exists. As stated before, two-way ANOVA and MANOVA are specialized way of ANOVA. Two-way ANOVA and MANOVA can be done in SPSS through general linear modeling. This is presented on your screen in this image. The output sheet of general linear modeling is complex and beyond the scope of the current lesson. However, the factorial designs are explained in detail in other modules. Friends, let's now summarize. In ANOVA, the dependent variable is metric and the independent variables is categorical. ANOVA involves testing the null hypothesis that the category means are equal in the population. ANOVA is an analysis tool which uses a set of algorithms to find the difference among the group means of a particular variable. ANOVA is associated with the statistical test to find if there is a difference in the means of groups being studied. Conceptually, the procedure is similar to t-test. Therefore, ANOVA is used to test and compare the means of two or more populations. The null hypothesis of ANOVA typically states that means that are equal. The alternate hypothesis of ANOVA states that there is a significant difference in the mean perception of the variables being measured. There is a 5-stage process for conducting one-way ANOVA and these stages have been discussed in detail in the current module. When ANOVA is conducted on two or more variables, interactions arise as a result of two-way or MANOVA is undertaken. Back. When ANOVA is conducted on two or more variables, interactions arise and as a result, two-way ANOVA or MANOVA is undertaken. These two are performed under general linear modeling. Thank you.